Welcome back, geometry students. This is our second video on volume of three-dimensional figures. In our last video, we looked at figures that had curves to them, the cylinders, the cones, the spheres, and how we found their volume, or how much liquid it would take to fill that type of container. We're going to look in this video at figures that do not have curves to them, but volume stays the same idea. How much liquid would it take to fill a container of that size and shape? So we're going to start off with a category that we call prisms, and prisms cover a whole wide variety of shapes. The first one that you're going to see in this Google slide is what would look like a box. So it's got a rectangular front, so we're going to call it a rectangular prism because its base, its bottom, and its top are also going to be rectangular. So this is that three-dimensional shape that you've been drawing and sketching and doodling for years and years. Okay. The length of the base is 14 centimeters. We're going to call this the width of the base is 4 centimeters. And then the height of the box would be our 6 centimeters. And I will say that my drawings are not to scale. Okay. The formula for volume of prisms is generic. It's going to be the area of the base times the height. And I really like in this example, if you think about one sheet of paper is a rectangle. We don't talk about how thick it is. It does have a thickness, but not very much. But if I take sheet after sheet after sheet and I stack them on top of each other, eventually I get that ream of paper that has that thickness to it. So that's what we're looking at here. Okay, if I just take sheet after sheet after sheet and stack it up, if I take the area of each individual sheet times the height of the stack, that gives me the total volume. That formula right here is going to change depending on the shape of the base, and we didn't draw our base here, but we do have that rectangle on the bottom. We'll see another example shortly with another shape on the bottom. Because we're working with a rectangle, our formula really becomes length times width, which is the area of the base, times height. And that's a formula that you're probably a little familiar with from previous classes. Rectangular prisms are pretty simple to fill in. I've got 14 is the length of my base, 4 is the width of my base, and 6 is the height of my prism. Okay. So I'm going to set that down. I'm going to grab my calculator. It's so good they put pockets in shirts to keep calculators in. 14 times 4 times 6 gives me a volume of 336, and it's still cubic centimeters. It's always going to be that cubic unit when we're talking about volume. And so I'm going to set that down and find the cap. But again, our review of this problem, okay, prisms, this is a rectangular prism, area of the base, which in this case is length times width, times the height of the figure, gets you its volume. Alright, and I'll erase that. I did find shower cleaner so that this will all come off at the end and get some nice clean look. Alright. The next problem, if you've pulled up this slideshow with me, is a slightly different shape. Now I'm going to be honest, my artistic abilities are not as good as computers can do. But in this case, what we're doing is we're taking a right triangle and we're turning it into a prism. It looks to me a little bit like a block of cheese. And so what you'll see here is that same triangle on the top and the bottom of the figure. This side it says it's 5 meters, this side is 12 meters, and this side is also 5 meters. So this is not a block of cheese because this would be a huge block of cheese. Maybe this might be the shape of a swimming pool if you decided to build a rectangular swimming pool or something like that that was pretty deep. Okay. Again, it's a prism, so our formula is to take the area of the base times the height of the figure. And we have this height of 5 meters over here, okay? But we've got to figure out what the area of the base is. And in order to do that, we need to know what shape the base is. In this case, that's the top and the bottom. And it's this right triangle. Triangles, if you remember, back to our area lessons, are 1/2 base times height, okay, times the height. And I want to put that in parentheses because those two heights are not the same. This is going to be the height of the triangle, and we're really going to focus on that 2-dimensional figure. Okay? And this is the height of the 3-dimensional figure, what gives us that cubic unit. So this right triangle, okay, the base we're going to treat as this 5 meters, and the height, kind of the altitude, if we want to pull in back from our learning in December, okay, the altitude is the same as the height, that's going to be the 12. So I'm going to take this 5 meters to be the base of the triangle, the 12 meters to be the height of the triangle, okay, that's going to be the same as down here. I could put a 5 and a 12 there. And if I really want to know this side, we could pull back our earlier knowledge on Pythagorean theorem. And then this 5 is going to come down to be the height. So again, E, H, and H, right there, height of the base, height of the 3-dimensional figure. So I'm going to type in 0.5 for the half, times 5, times 12, times 5. I'm going to get a volume of 150 cubic meters. So if I'm filling up this swimming pool, that's how much water I'm going to have to fill in there, although I'm going to have to go learn how to convert from cubic meters to gallons because we use the English system and not the metric system, although the metric system's better. Okay. So please keep that in mind. Okay. But again, rectangular prism, area of the base, in this case the area of the triangle, times the height of the figure. Okay. Alright, one more problem then. Stick with me here. And in this problem, we're going to look more specifically. I'm going to clean that off a little bit better so that we can see this one in detail. And in this last figure, we're going to look at a pyramid. Now, I really wanted to try to get like the dimensions of like the Great Pyramids in Egypt and things like that. And maybe that's something we can look at a little bit later. But in this problem, what we're looking at, I'm going to try to sketch it, is a pyramid with a square base of 10 meters and 10 meters. So still a pretty big pyramid. Okay. And you're seeing dashed lines there. I know it's a square because the two sides are the same. And then we're going to kind of draw this point up here and dash to there. Kind of goes down to each corner. Again, my art skills, not awesome. Then we see the height of the pyramid, and this is dropped straight down to the center of the base over there. Okay, again, excuse my art skills there. But this, 9 meters, that's the height of the pyramid. Okay. The volume formula for pyramids, sorry, I'll make that a V. Okay, volume formula for pyramids is very similar to the volume formula for prisms, and much like we saw with cones, we're going to see that 1/3 pop out front. And so we could fit 3 of these pyramids inside of a prism that size. Okay, so 1/3, and then you're going to see the area of the base times the height. In this case, that base is a square. So 1/3 times, remember, side squared, or just length times width, either one. Okay, because they're both 10, they're the same. So 1/3 times the 10 squared times the 9 meters is the height. And in this particular one, because 10 meters is pretty big, it's 33 feet or so. I don't imagine this is a mini pyramid and it's filling up with sand like in a Mario Brothers video game or something like that. So how much sand would it take to fill this in? Okay, I'm going to grab my calculator. I'm going to do 1/3 times 10 squared, or 100, times 9. And that's going to give me a volume of 300 cubic meters. Okay. Right, so again, the recap here with pyramids, very similar formula to prisms, but you've got to multiply by 1/3 to tie that in. that area of the base is going to change. You could have a pyramid with a triangular base, you could have a pyramid with, say, a pentagonal base or a hexagonal base, but in this case we had the square, so we saw its area formula. Thanks for watching these. Go back through, check those out as you're doing your work here. There will be one more video that will show up some general stuff about volume, but this is the basics of what you want to do to use those formulas. If you have any questions, make sure you're reaching out to your teachers here, and feel free to join us for office hours, and I hope you have a wonderful day.